Hello guys, my name is Adrian and welcome to my channel. If you are new to the channel, I'm trying here to create a small game framework in order to be used for a game that I'm developing live on stream, of course, here on the channel. Last time I showed you how to, let's say, load OpenGL functions, an alternative to libraries like GLAD, a very well-known and very popular function that provides the, let's say, OpenGL functions and of course a loader for them. So today we'll continue our journey with OpenGL, and I already, in order to not spend time live here on the video, I created the definitions for three important functions for buffers. We have the create buffers, the delete buffers, and the buffer storage. Okay, for the create, of course, the first parameter is how many buffers do we want to create, and the same applies for the delete buffers function. And the second parameter for both of them, it's a pointer to the buffers. Buffer storage takes a buffer, some size, the memory address for that buffer, and some flags at the end. Now I already loaded here in the init buffer functions. I already made use of the let's say of the functions, and what I did specially, I named this buffer storage, and also this is the pointer function. I also name it just GL buffer storage, but in fact what I'm targeting is the GL named buffer storage function. This is a function that you can find in, let's say, newest versions of OpenGL. This is much easier and also follows the direct state access principle, a principle for OpenGL that makes it more appropriate or more closer to Vulkan. Not especially in terms of performance, it cannot match the performance from Vulkan, but it kind of compared with the old implementation or old versions of OpenGL, it's much better. So what we will do today? Today, into our core folder, into the graphics modules, because my engine is kind of split in modules, I will make a new directory which will be called buffer. Okay, and inside I'll create a new header which will be called data. What I want to do for the core, a new header, of course, headers HPP, and inside, of course, I will include the buffer data. And what we need to do, of course, target precompiled headers, because for those that are new to the channel, we are using CMake as a build tool or building tool, how you want to say it. So let's use headers here. And now let's make a short build. Okay, and what we will have here, very simple, into the data namespace core buffer, because with the namespaces I like to keep the hierarchy or the structure for the folders. So we have core buffer, and in here I will have a short struct data called data, and I will have a constant size member, and another one will be a void pointer called ptr, short from the pointer. I would like to align this because this is a thing that I personally have. I like to align things. And what I will do further, I will make a template function, okay, which will, of course, take a type name, and I will not use t, I will call it type. Okay, this is a personal preference. And of course, static auto, and I will call it make data. In here, for the, let's say, as a parameter, I will use a std vector Of course, I'll use the type as the type for the vector, and I will call it, I don't know, vector. Why not? And I will return some data. Inside here, of course, I need to make sure that I'm using the vector, and that should be pretty much. What I will do here, return. I need to, of course, to return a vector, a data, sorry. So I will use vector size multiplied with size of. I will use type here. And for the second parameter, I will use the pointer to the data of the vector. It is more like an util class. It doesn't have any, let's say, functionality, but it's much easier. Instead of writing this line of code every time, I can kind of like a shortcut. I'm just using this static function, and probably it can be optimized by the compiler at some point. So for now, this is what we need. And what we do further. Further, we are doing one small thing. We will have, we need to create a new, let's say, a new class inside the OpenGL function, and we'll call it object. Okay, of course, we need to be sure that object it's added to the CMake sources. Very important, this aspect. And inside here, instead of the core namespace, of course, we'll have OpenGL. Let's make also a build in order to be sure that we have access. Okay. This file should belong to something. Okay. Okay. So let's also put OpenGL here. We have OpenGL here, and that's okay. So what I want from this object, I want two things. Something public, something private. We'll have a UI int 32 type, which will be the handle, because every OpenGL object will return for us an unsigned int. Just a second, I will move very quickly this here. So we have a handle, and later on we can have, for example, something called, why not, info or extra, depends on how, or meta, depends on how you want to use it. Okay, but I'll just call it info. So we are having the handle. What remains for us, each OpenGL object will have a virtual auto create void function, and of course virtual auto destroy. Just a second. Okay, so we have create and destroy. Of course, the virtual destructor, and later some handles for the info and something for the some getter functions for the handle and something for the info. Okie dokie. What we need, of course, to do here, let's generate this for the handle, and let's generate this for the info. That's very simple. Okie dokie. So further, what we are doing, we are creating another class called buffer. And for the buffer, we need to do the same here. We need to be sure that buffer CPP is included into the project sources file. And in here, very simple, we need to change, of course, the namespace to OpenGL. Okay, the same for the buffers, OpenGL. And what we are doing for the buffer, the first thing that we are doing include objects, final, and we do a small inheritance from the object. And in here, we'll have create and destroy as mandatory functions. And another thing that we'll do, it will be storage. And we'll have a core, buffer, data, we'll call it data. And of course, at the end, we'll have some flags, which by default, I want to initialize them as 0. Okay, let's generate these two things. And now, if we are going like functions, create, just a second, my AI kind of intervened. So we'll have functions buffer, and in here, like I said, very easy, we'll have functions create buffers. We'll put 1, and we will try to put the handle as the place where the memory should be filled. Later on in our journey, we'll create a small, let's say, buffers manager, which will kind of try to create or to call this function just once instead of for each buffer to kind of have a call. This is also the behavior for Vulkan. You can kind of create buffers in bulk. So this operation will be later on added also for us. The same technique applies to the delete buffers, like for the create. And the difference is like for functions, buffer storage, we'll use the handle here. We'll have the data size, the data pointer, and at the end, we'll use the flex. That simple. The current implementation of our buffer kind of allow us just to have, for example, just some data. So we are allowed to create a buffer, to destroy it if we want it, and to put information in it. What we kind of added today, it doesn't mean that we can draw something on the screen yet. Okay, so we can have something like include OpenGL buffer. And what we can do after we initialize the situation here, we can have something like, or after, doesn't matter, OpenGL, let's say buffer, and we can have something like, let's imagine that we want to have a square. So we have square, and let's call it VBO, vertices buffer object. Okay, and what we are doing with it. Of course, square VBO, we create. Okay, it's very important to create it. Of course, at some point, we can delete it. So it will be better to be deleted here. Destroy. And in here, we can have square VBO storage. And for this, we have something like core buffer make data, and we are expecting to have a vector. The information that we can send, it's something like this, for example. We can have like floats, which represent the position. So we can have something like square vertices. And in here, we can fill it with the information for the square. And of course, this can be sent as a parameter. If you remember correctly, storage has another parameter, which is the flags. By default, we send 0 because it's put as an optional parameter here. 0 means that the buffer uses the storage as a static drawing. Okay, it means that we don't want to kind of change it. Also, another thing is that we are using storage, the storage function, which means that the data, once we allocate it, it cannot be changed, but it can be changed if you kind of update the data with the same size as the buffer was initially, let's say, created or allocated with his memory. If you want to put, for example, in this buffer more memory, you cannot. Okay, you'll have a problem, and that's it. But in terms of performance, the buffer storage offers you a better, let's say, performance than the old classic way of putting the data for a buffer. What we will use this buffer for? So we have our buffer. We don't have yet some data in it. Okay, I will complete it offline. I don't want to bother you with this information for now. So we are having this buffer. This is what we need to have some buffer. How we are using this, or how it is used, in order to, for example, in this buffer, we will put the information that represent the positions of a square. Okay, a very simple square, just with position. We'll not have textures, lighting, and any other attribute. We will have just positions. So the whole idea is that for the GPU, you kind of need to have something called vertex array, or vertices array, how you want to call it. There is a vertex array object, and this is kind of responsible, or this is like, let's say, in the GPU part, on the GPU side, this is how the GPU knows how to map the information, let's say the input information. It's like you want to say that, hey, I have some geometry that has normals, positions, textures, all that stuff. So with the vertex array, you are kind of saying to the GPU and to the shader, of course, how the memory is set, the layout of the vertices. And of course, for a vertex array, you can attach these buffers. You have vertices buffer object and elements buffer objects, or indices buffer objects, like many others know or name it. And now, I think this is enough for a buffer. What is very important for you to know for now is how to create a buffer and how to send some data inside it. In the next video, we will approach the vertex array class, or vertex array object, and we will see, of course, how to attach a buffer to a vertex array in the new and modern way, not the old way with bindings and all that stuff. No, we are not using that. No binding for us. And what we'll do in another video, we will use some draw commands in order to, of course, successfully draw the square on the screen. So I think it's enough for today. We have the buffer class. In the next one, we will approach the vertex array, the drawing commands, and we will already have something on the screen. If you're new to the channel, don't forget to subscribe. It's a good chance. We will do nice things around here. We'll approach math, physics, pathfinding, and all that stuff. And if you like the video, a like is very appreciated. It helps the channel, and we can continue to do the good job here. So, thanks for watching. Have a nice day, and see you in the next video. Bye bye.